This is a continue on video where I'm working on breathing, the 3.3 achievement standard possible test. I'm looking at question 5, which is the practical problem, where they're actually looking at using trigonometric equations to actually be able to model something practical that's in a sinusoidal or just an up and down type of model. In this particular one here, it says it's on lungs and it has a minimum of 300 and a maximum of 700, and it gives the period or the time for one breath, which is from having no air in your lungs to full air back to no air again is 5 seconds, and they've said that that's one whole period. It doesn't actually say here where you actually have to start this particular model. I see on the answers there that it actually started with it had completely exhaled. It doesn't say anywhere that you have to start it with completely exhaled. So I always try to make it the easiest and start with a maximum. So if you're not told anything, you start with a maximum. If you're told exactly where it has to happen, then you must plot it like that. The way in which you approach all of these problems is you must draw a sketch. And that is the fastest and easiest way. That is also the minimum expected working that you're going to have to show. So in this one here, it's got a maximum, I'm going to do a maximum here at 700, and a minimum at say 300. And I know that after 5 seconds, so if I do here at 5 seconds, and I'll do another one here at 10, at 5 seconds I will have a complete rotation. So that means at about 2.5 seconds, if I start a maximum there, I must have a minimum there, and then back up to a maximum there. And then at 7.5 seconds I'll have a minimum, then back up to a maximum. So I must have a graph that looks something like this. And up, and down, and up again. That's about as rough as it needs to be drawn. It doesn't need to really be drawn any more accurate than that. It's just a quick sketch. Now from the sketch, you can get the equation of the model. So the first thing that you'll do is you look at the gap between the top and the bottom there, that there is 400. So that whole distance there is 400, which means from the middle there, it's up 200 and down 200, which means that you know that the model starts with 200 cos something. I haven't got a shift left or right, so I'm just going to have an X, or actually in this case, I might as well put it, since it's a model, we'll just put it as a T. Next thing that you want to know is you want to know where that middle line is. That middle line is halfway in between, so it's up 200, so it's at 500. So there must be a plus 500 on the end. And the last part is we actually want to know what the frequency is. Now the frequency is always 2 pi divided by whatever my period is. Period is when it goes from a maximum back up to a maximum, or from a minimum back to a minimum. So the period in this case is 5. So that's how we established the equation. We took it all from the properties of the graph. Right, the next thing it says, after how many seconds does the lung hold 400? Of course, this one's going to be different to the answers because I didn't have to start at a minimum, I started at a maximum. So anyway, we'll look at how we do that on our calculator. First thing you do is you make sure you go into menu. You start off in the general place and you go shift menu to get into setup, and check that you're in radians. You should always be in radians for a practical problem. Right, next thing that you do is you want to go into graph, and when you get into the graph you just type in your formula here, which is 200 cos, oh, I actually typed cos instead of I actually typed that all on the keyboard there. I'm not too sure what would have happened there. So let's actually try this one, 200 cos bracket. Now I'm going to do the 2 pi, so this is just going to be 2 times pi divided by 5 times x. Because this is bed mass, it should actually do this all over the same thing. It should actually do it just from left to right, so I shouldn't have to put any extra brackets in there. Then this here is just plus, this here is then just plus, again I did on my keyboard, plus 500. Right, next thing I want is I actually want to check my x-axis. Now I'm starting at 0, and I'm going to finish up, say, at 10 seconds. Next thing I want is my y-axis. I could start that at 0 to 700 would probably be good for me. So if I arrow that down, missed the arrow back up. So if I'm at like 700, see how I put 700 in the minimum? If I actually put 700 the minimum and the maximum 300, if I've done it around the wrong way, it's actually just going to draw the graph upside down. So you know if you've done something wrong, if the graph's upside down to what you expect, it's 300, execute, and then 700. I was going to start it at 0, but instead I start at the minimum. Right, if we draw that, looks very similar to the one that I've already sketched. Then how many seconds do the lung hold? After how many seconds do the lungs hold 400 centimeters cubed? We'll take that from the start, so it's the first time it is 400. So we just go Shift G solve, arrow across to the next one. We want an X calculation, and we want when is that 400? And the very first time is 1.666. So question B is 1 2/3, because 1.666 seconds. Because this is all in seconds, we don't have to worry about, we could have said 1.66 seconds. It's not like when you have the hours and the minutes, and it's not like when you have a time when you have to write that. This is a slightly different model from some of the ones that we've been doing in class. After 4 seconds, what do the volume and the lungs hold? So all we have to do now is just Shift G solve, arrow across. Now we want a Y calculation, and we want that when X equals 4. So we type in 4, and this time we get 561.8. So C is 561.8 centimeters cubed. It is good to write the units, but you won't necessarily get punished for that, not having the correct units. Now, a real typical sort of a question, it's actually not in this particular practice test, is something like when they say, I don't know, when would be the first time, or how long in the first 10 seconds is it below 350? So if they had a question like this, how long in the first 10 seconds is the air below 350 centimeters cubed? Typical sort of question. Right. So when we're finding this here, what we need to be able to do is, again, we go back to the graph, and there's, if that's, there is 300, and that's 500, so 350 would be about here. So what we do is we draw a little line across. And if it's below, that means that we want to know these times here, and here, and here, and here. So we actually want to know that distance in there, the distance between those times. So what we do is we work out whatever that time there is by subtracting this from this, and then we work out this time here by subtracting this one from this one. So the only thing we've got to figure out is how we're actually going to get these values here. So what we do, again, we go back to our graphics calculator, and on our graphics calculator, what we want now is, again, you go back to Shift G solve, and we know what the Y is. We need an X calculation, and it is when Y equals 350. So we put that in, and there's our first one, is 1.92. So I'd go 1.92, and I'd write that down on my graph. Normally you would take 4 decimal places, but just for this, to make it a little bit quicker, I'll only take 2. Then you arrow across to the next one, 3.08. So the next one is 3.08. The next one is 6.92. So this one here is 6.92. And the last one, if I arrow across, is 8.08. So this here is 8.08. So all I have to do now is I just have to subtract each of those to find out what the gap is between them. So again, I grab the trusty calculator, and I just go 3.08, said 13, 3 0.08 minus 1.92. That is 1.16. So if I go up to here, that is 1.16 seconds. And then if I go to the next one, it is going to be 8.08 minus 6.92. And that is again 1.16. You'd sort of hope so because it should really be symmetrical. So 1.16. So then all we have to do is just go 1.16 times 2, because there was 2 of them. 2.32. So how long in the first 10 seconds is the air below 350? 3.32 seconds. If this was in hours and minutes, you would then convert that into hours and minutes. Just because it's in seconds, you don't have to do that. Okay, so that's basically how you do the practical problem.